The students of our test were all between the ages of 19 to 25 years old, and for the most part they were all healthy individuals. There were also equal parts male and female subjects, so there was a good balance between the two genders. For our group project, our group chose to select 3 tests that we felt would demonstrate the cardiovascular endurance and muscular endurance of our subjects. We chose these tests because the STEP test is a pre-established test that would give us a good evaluation of one's cardiovascular endurance. We chose to have the jumping jacks be our second cardiovascular endurance test because we thought that we would be able to see a positive correlation between this test and the YMCA STEP test. We also chose to use the side plank as our third test because we thought that there isn't much skill required, if any, other than maintaining form, so we thought that this test would be good to use for a group of wide-ranging ability levels. We were hoping to find that the participants' scores for Test 1 and Test 2 would positively correlate since they were both measures of their cardiovascular endurance. We were also hoping to see some reliability between the 2 trials for our plank test as well as our 2 trials for the STEP test. The YMCA STEP test was our pre-established test that we chose from the Guidelines for Testing and Exercise Prescription textbook. Depending on their post-exercise heart rate, they fell into one of the categories for males or females. We made up the jumping jacks test in order to correlate the cardiovascular endurance of the subjects with our STEP test, and we chose this exercise because we thought everyone would be fairly familiar and comfortable with the technique used while performing jumping jacks. We did not want to make up a test that would take the subjects a number of tries at to become comfortable with because that would have thrown off our results. As a group, we learned that making sure the subjects were comfortable and had a good understanding of what they were being tested on made them much more confident and able to perform the tests to their best capabilities. The process of collecting the data for all of these tests was challenging at some points because for the day we performed our test, there were 22 subjects present, and for the STEP test, we only recorded 21 subjects. This meant that the subject did not participate, nor did they inform us that they were not going to participate. Also, one subject stopped the jumping jacks test short of the 90 seconds that the test was designed for, so that also brought down the data for that test. If we were able to conduct these tests again, we could have created an order that the subjects would perform the tests in and have them rotate through. This way we could easily keep track of who had performed which test. When we administer our test, there was no order and the subjects just went to whatever test was available. We could change that for next time we administer these tests, and that might have cut down on some of the difficulties we experienced.
The mean or average for the YMCA STEP test recovery heart rate was 87.06. This was around the 75th percentile, which means that most of the subjects were relatively healthy. The median or middle number when the scores are put in order was 87. The mode or most frequent number was 97. The standard deviation, which describes the scatter of scores around the mean, was 12.99. A frequency distribution is used to describe a data set with interval or ratio data. This shows a frequency distribution for recovery heart rate. It shows the scores or heart rates in beats per minute, the frequency of them occurring, the cumulative frequency, and the cumulative percent. A t-score is a form of score standardization. It expresses how far a number is from the mean in positive numbers from 0 to 100. These scores were calculated from the recovery heart rate. The t-scores ranged from 33.10 to 66.97. A z-score also shows how far a number is from the mean, but in terms of standard deviations. These scores can be negative, 0, or positive. These scores were calculated from the jumping jacks test. The z-scores ranged from negative 3.8 to 0.92. Correlations show relationships between 2 variables. A Pearson product moment correlation is used when both sets of data use interval or ratio data. Recovery heart rate from the YMCA STEP test and the jumping jacks test were used to calculate this. The value found was negative 0.12. The linear regression equation calculated was y equals negative 0.1939x plus 107.197. This correlation was in a negative direction, it was not significant, and its strength was no relationship because it was between 0.00 and 0.19. This graph shows the Pearson correlation scatter plot. It shows a negative direction. There is one obvious outlier, which may have thrown the correlation coefficient off, which then caused the correlation to have no relationship.
The Spearman row is used when one or more groups of data are ordinal measurements. We used this to compare test 1 and test 2 of the side plank test. The equation gave us a correlation coefficient of 0.57. We used a t-test to determine if there was a significant difference between test 1 and test 2 of the side plank test. The t-test was a dependent t-test, having tested the same group at 2 different points. We expected the second test to have times that were significantly shorter than the first due to muscle fatigue. After calculating the t-test, we found there was no significant difference between the two. In order for the data to have a significant difference, the t-test would have needed to produce a value greater than 2.08. The value 2.08 was found using a t-test significance table. Here, the bar graph demonstrates the slight decrease in times. In order to determine the validity of the recovery heart rate test, we made a chart that classified participants as masters and non-masters and whether the participants were trained or untrained. In order to be considered trained, the participant had to complete 10 or more hours of physical activity per week. To master the test, the participant had to have a recovery heart rate of 87 beats per minute or less. We added the two expected numbers together, which are the mastered trained and non-mastered untrained. We received a validity coefficient of 0.48. According to the Personnel Assessment and Selection Resource Center of the U.S. Office of Personnel Management, a validity score of 0.30 or higher is useful in most circumstances. To estimate the reliability of the side plank test, we developed a contingency table to be able to calculate the kappa coefficient. This test classifies participants as masters of time 1 and time 2, masters of time 1 and non-masters of time 2, non-masters of time 1 and masters of time 2, and lastly, non-masters of time 1 and time 2. In order to be considered as mastering the test, the subject had to do a side plank for longer than 75 seconds. After calculating the proportion of agreement and the proportion of chance, the kappa coefficient could be found. The kappa coefficient was 0.24, meaning the test was not reliable. The histogram graph on the left demonstrates recovery heart rate in percentiles. The histogram graph on the right groups participants based on the amount of jumping jacks they've completed.
Using the Pearson correlation, we found recovery heart rate and jumping jacks to have an insignificant correlation. Correlating the recovery heart rate of the step test and number of jumping jacks, the correlation was 0.12, which is less than the accepted value of 0.433, proving to be insignificant. The class as a whole produced an average result of 87.06 beats per minute for recovery heart rate, which is a healthy heart rate for young adults. We then tested for the validity of this test using the validity coefficient formula. The validity coefficient we determined was 0.48, which is acceptable in most circumstances. The side plank test results were not reliable. Using the t-test to analyze differences between the results of round 1 and 2, the side plank test revealed no significant differences between the two sets of results. Our t-test value was 0.59, less than the accepted value of 2.080. However, according to the reliability test we performed using a contingency table, the side plank test was not reliable for this class of participants. Our kappa coefficient result was 0.24, which is much lower than the accepted value of 1. According to a study done at Stanford University, the accuracy and reliability of core ability was assessed by using side planks. Testers used Pearson correlations to assess differences in data and the test-retest analyses for reliability of the testing procedure. Like our group, testers did not find any significant differences between their data sets, but they were able to find their test reliable through the test-retest and inter-rater reliability tests. Several limitations during our tests can account for the unreliability of our tests. We identified several sources of error during testing that could affect our reliability and validity. Being new to administering exercise testing, our group was slightly unorganized. For the Pearson correlation, effort put in by participants alone could have affected our results. For the side plank test, many students influenced the results by stopping when they saw others stop. Also, due to time constraints, both side plank tests were not tested consecutively because we were conducting 2 other tests simultaneously. We would prefer to test them consecutively with adequate rest. We expected both cardiovascular endurance exercises to correlate significantly. However, our results showed us differently due to participants' effort and procedure. Ideally, we would prefer to do this research project in a more controlled environment, giving only 1 test at a time without interruption. Despite our invalid tests and unreliable results, this project allowed us insight for future exercise testing.